Our final question of review exercise 1 is question 32. And in part A, we are asked to sketch the equation y equals 1 over x squared or minus 4. Now, in order to do this, I'm going to refer to a better known graph, y equals 1 over x squared. This is a transformation of this one. It's been translated 4 units down. So instead of having an asymptote at y equals 0, we're going to have an asymptote at y equals minus 4. It will have the same general shape, only translated downwards. That does mean we now have these 2 points here. Now we're asked in the question to state the equations of the asymptotes. It's worth noting there's also an asymptote at x equals 0 as well. We are also asked to find these intercepts. There is no y-intercept, but we do have these x-intercepts. In order to find that, I know that any point on the x-axis will have a y value of 0. Therefore, I will make this side of the equation equal to 0. Adding 4 to both sides, and then multiplying both sides by x squared and dividing both sides by 4, and then square rooting both sides, I find 2 solutions, minus a half and positive a half. And that completes part A. In part B, we are told the curve with equation y equals 1 over x plus k squared minus 4 passes through the origin. Find the 2 possible values of k. So we've got this original transformation, but now we have a new one. This transformation is inside the brackets with the x. So what that means is it will affect the curve by transforming it with a horizontal translation. If I slide it to the right, that point would move to the origin. If I slide it to the left, this point would move on to the origin. I would need to slide it by half a unit in either direction. So I know that k could either be minus a half to translate it to the right, or a positive half to translate it to the left. And either one of those would cause the curve to intercept at the origin.